Today, we'll be talking about the cosine and the sine function.
These are the things we'll cover today.
Now moving on to learning goals. What will you be able to learn after watching this video? Well, you should be able to understand the sine and cosine function as well as its properties. You should be able to transform sine and cosine from the base graph and graph functions when given transform equations. You should be able to complete application problems and be able to gather and collect information.
So these are the two main graphs for sine and cosine function. So y equals sine of x is the green one, and y equals cos of x is the blue one. For sine of x, it starts at 0, and for cos of x, it starts at 1. First, talk about the sine curve. The sine curve can be generated from a circle by plotting the rotational angle and the value of sine as x and y. So the value is x and y. The unit circle is also involved in the sine and cosine function, but what is it? Well, a unit circle is a circle with a radius of 1. The center of the circle is put on a graph where the x-axis and the y-axis cross. We use the unit circle in order to help us graph the cosine and sine function. Now let's talk about the sine function. Okay, so you start off here at 0, then you go up for 90 degrees to 1, then you go to 180, then for 270 go to -1, and then go back to 360. Points your unit circle, our 5 key points are 0 and 0, 90 degrees and 1, 180 degrees and 0, 270 degrees and -1, and our last point is 360 degrees and 0. Now let's talk about the sine function properties. The domain is x equals any real number. It's more than -1 or less than 1. So it would be so your period is 360 degrees. So your amplitude, which is half the distance between the maximum and the minimum values of a period function, is 1. So this is 90 degrees, this is 180 degrees, 270 degrees, and this is 360. So visual would be like start at 1, then go to 90 degrees, then for 180 degrees you go down to -1, and then you go to 270, and you go all the way up to 360 again. So the key points discussed as earlier is 0 and 1, 90 degrees and 0, 180 degrees and -1, 270 degrees and 0, and 360 degrees and 1. The domain and range are the same as sine function, which are x is any real number and our range is y that must be less than 1 or more than -1. Your period is 360 degrees and the amplitude is again 1. Before we go on to the next topic, I just wanted to talk about what each of these variables mean. So A is your amplitude, so A equals max minus min over 2. The period, which is represented by the k value, is 360 degrees over k. The k value tells you the number of cycles that occur in 360 degrees. The equation of axis is vertical translation up or down, which is represented by y equals maximum plus your minimum divided by 2. And your phase shift is horizontal translation, either going left or right.
So now we'll be talking about transformations of the sine and cosine function. So these are the transformation equations, but what does each variable in this equation represent? To start off, we'll be talking about our A value. So A determines the vertical stretch and compression. If A is more than 1 and less than -1, there is a vertical stretch. So if the base graph were to look something like this, our A value, if vertically stretched, would be something like this. Now, if A is less than 1 but more than -1, the function is vertically compressed. So if A were to be 0.5, then it would be vertically compressed. So if our base graph were to look something like this, then our new transformed equation would look something like that. So if our a value is negative, that means that there will be a reflection on the x-axis. So if our graph were to look like this, the reflection would result in the graph looking like that. So K determines the horizontal stretch or compression. This means that it tells you the number of cycles that occur within a 360-degree horizontal distance, aka the period. For example, to find the period for a graph that's 180 degrees long, we must do 360 divided by 180, which is equal to 2. Our d variable, which is basically the phase shift, or in other words, the horizontal translation. So if d was positive, then our function will move horizontally to the left, and if d is negative, then our function will move horizontally to the right. Depending on whatever the sign is in front of the number, it will move the opposite of it. C is the equation of the axis, or in other words, the vertical translation. In order to find the value of C, add the maximum and minimum value together and divide it by 2. If C is positive, then the function will move up. If C is negative, then the function will move down. Now that we know what each variable represents, let's try some examples. Y equals 4 sine bracket 2 bracket x minus 135 degrees, close bracket, minus 3. So just by looking at this, we automatically know that our a value is 4, which means that there is a vertical stretch by a factor of 4. K is 2, which means that it is horizontally compressed by a factor of 0.5. In order to find the period of this equation, we must do 360 divided by 2, since our k value is 2, which equals to 180. So this is how long, if we were to graph it, this is how long the equation would last, one period. Our d is negative 135, and d is negative, which means that there will be a horizontal translation of 35 degrees to the right. And finally, our equation of the axis, aka C, is y equals negative 3, which means that our graph will shift down by 3 units. Now let's move on to graphing the sine and the cosine function. Now, there are some steps when graphing a cosine and sine function. The steps are to start off with a period, then work on the phase shift, reflection if the equation gives a reflection, the equation of axis, and finally your amplitude. So let's try graphing one cycle for the equation. Y equals negative 3 sine 1 over 4 x minus 50 plus 7. So let's look back at our steps and see what we must complete first. So according to our steps, we must complete the period first, so our k value. So as mentioned earlier, in order to find the period of our transformed equation, we must do 360 divided by our k value, which is 1 over 4, or 0.25. So 360 divided by 1/4 is equal to 1,440. This means that our period is going to last for 1,440 degrees. Now we must find our new 5 key points. Let's recall back to our last lesson, or our first lesson, when we were talking about the sine and cosine base functions. Our 5 key points for the sine function were 0 and 0, 90 and 1, 180, 0, 270, negative 1, and 360 and 0. In order to find the rest of the x-axis key points, we must divide 1,440, our period, by 4, which is now 360. Now we must continue to add 360 4 more times in order to find the rest of the 5 key points. So our first key point is automatically always going to be 0. Our second key point is 360 because of what we did earlier, which is 1,440 divided by 4. Our third key point will be 360 plus 360, which is 720. Our fourth one will be 360 times 3, which is 1,080. And then our fifth key point will be 360 times 4, which is 1,440. this. Okay, so now let's move on to our second step when graphing a function. So let's move on to our phase shift. So according to equation, we must shift our graph 50 degrees to the right since it's negative equation. So this means that we must move our 5 new key points 50 degrees, aka add each 50 degrees to the right. So basically our 5 key points were, due to our previous step, were 0, 360, 720, 1080, and 1440. So we must add 50 to all of these. So our new key points will be 0 plus 50, 50, 410, 770, 1130, and 1490. So our next step when graphing the sine and cosine equation is to focus on the reflection if there is given. And as we can see, there is one given. So as you can see by our equation, we're dealing with the sine function, which means that the base graph starts in the middle and gradually goes up and then back down. So like this. So since there's a reflection, our thing is going to flip by the x-axis. So our graph will look roughly something like this. So it'll start at the middle and gradually go down and then up. So our next step is to focus on our c value, which in this case is 7. So this means that our graph will vertically shift 7 units up from the base function, which was 0. So this is how our graph is looking so far according to our steps that we just did. So now we're going on to our last step, which is to focus on our a value. In this case is 3. So in order to find the maximum height, we will add 3 to 7, which is 10. And to find the minimum height, we'll subtract 3 from 7, which is 4. Okay, now that we have completed all the steps in order to graph, we are now able to actually graph our equation. So since it's a sine function, we start off in the middle. So let's start at our first point, which is 50. And due to the reflection of A, our graph will go, instead of going up, it will go down. So 410 will be at 4, and then it will make its way back up, and then up again to 10, and back down to 1490. So our graph will look like that.
Okay, so now we're going to start on an application problem. So number 1, the water at a pier is 42 meters high at high tide and 28 meters at low tide. One cycle is completed every 10 hours. So part A, draw a graph for the 20-hour cycle starting at high tide. So for our scale, the maximum would be 42 meters high since it's our high tide, and then our minimum would be 28 meters since it's our low tide. The equation of axis would be 35. We know this because 42 plus 28 is 70, and then 70 divided by 2 would give us 35 meters. To find our key points, which is right here, we did 10 divided by 40. So our first point would be plotted at 42 because it's starting at high tide. Then the second point would be at 2.5, and then the third one would be at 5, and then back to 7.5. So part B to this question would be write the sine function for the previous graph. So first we have to find our amplitude. So to find amplitude, we do our max minus min divided by 2. So in this case, our maximum was 42 and our minimum was 28, and then we divide that by 2, and our amplitude would be 7. Now we have to find our period, which is our k value. So in this case, we do 360 divided by k. So 360, and then our period in this case was 10, and that would be 36. Next we have to find the equation of axes, so that would be our c value, and how we find that would be our max plus min divided by 2. So our maximum again was 42, and then our min was 28, and we divide that by 2 again. And that gives us 35. So next we would have to find our d, which is our phase shift, and d would equal to 7.5. It would be 7.5 because that's how much you would have to shift to the left to get your sine function. So part C of this question would be write the cosine function equation for the same graph. So since we already found what our a was, we can just write that down. And we also found our c previously, and that would be 35. We also found our k, our period, which was 36. There is no phase shift in this case because our graph starts at the maximum and cosine always starts at the maximum.
That's all for sine and cosine function. Thanks for watching!